Okay, share again. And we'll start our business meeting. Welcome, everybody, and thank you for coming out tonight. And the slide's not changing. There it goes. I'll call to order our Chapter 22 business meeting. And Vinny, you can read the minutes from our March meeting.
All right, I got to read them off the screen because my printer is not working tonight. Let's let George back in here first. All right. Minutes of the meeting, March 16th, 2022. Meeting was called to order at 7:10 p.m. by Tom. Minutes of the February meeting were read. A motion to approve by Tom, seconded by Pete Peters. Motion passed. Treasurer's report. The chapter is now insured. The policy has been received and sent to the secretary. Also, the bill has been received and paid. Our taxes have been e-filed and registration and payment sent to the New York State Department of Law for our nonprofit certification. A motion to approve by Vinny, seconded by George. Motion passed. Certification, nothing to report. Old business, none. Frequency coordination, received an experimental authorization notice from Lockheed Martin on a construction permit for 2 megahertz to 1800 megahertz at 0.001 milliwatt ERP, expected to begin in mid-April. In new business, Eric Shofner of Infinite Electronics will be the April presentation. We have a new member, Stephen Jaquin of Cazenovia. National notes were read. Certification exams June 3rd through the 13th. Applications for that due by April 15th. The national membership drive has begun. Under Expo, it'll be September 29th at the Ramada Inn in beautiful Liverpool, New York at exit 37 of the New York State Thruway. The national meetings will be on the 28th and 29th. All contracts have been signed. The chapter officers met with Executive Director Jim Ragsdale on March 11th. The website has been updated and database cleanup is in progress. Booth rates remain at $750. A motion to adjourn by Tom at 7:20 p.m., seconded by Jim Peck. Motion passed. The program for the evening was Rode Microphones, presented by Ryan White, U.S. Product Specialist. And that's the minutes.
Anybody have any changes or disputes with it? If not, who would like to make a motion to accept the minutes? Chapter 22 member, please. George, who would like to second that? Pete, all in favor, say aye.
Aye.
Opposed, say nay. Accepted. Gary, treasurer's report.
Okay. We have a few vendors signed up for Expo 22 Expo 22, and their payments are magically appearing in our bank account, and all the officers should have received a copy of the current bank statement.
Yeah, I got mine.
Okay, and the state of New York cashed the check that Vinny just referred to in the minutes.
Yay!
They just cashed it yesterday. That's it. That's it for the treasurer's report.
I'll make a motion to accept the minutes. Who would like to second that?
I'll second it.
All in favor, aye.
Aye.
Opposed, say nay. Gary, frequency coordination and certification.
Okay. This week I received an email on behalf of Dish Network Corporation regarding proposed AWS site locations. for the Syracuse, New York market. They will operate, among other things, in the AWS-4 frequency range from 2000 to 2010 megahertz, 2180 to 2190 megahertz, and block B, 2010 to 2020 and 2190 to 2200. In other words, from 2000 to 2020 megahertz and from 2180 to 2200 megahertz. How this goes together with GIS network, I'm not totally sure, but the technology being deployed is 5G mobile broadband based on 3GPP release 15 and successor releases. If anybody wants to see a map of where the transmit locations are located, Tom, if you let me share my screen, I can show you the map.
No. Go ahead.
As you can see, there are a lot of sites around Syracuse, and
You're not sharing yet.
Yeah.
Okay.
Nope.
Let me go back here.
There you go.
Okay. Had one more thing to click.
Oh, wow.
Yeah.
You can see there are quite a few right around Syracuse, a number around Utica.
Yeah.
And they don't provide any additional information on those. So
Can you give me those frequencies again?
sure. Okay, the frequencies will be from 2000 to 2020 megahertz, and from 2180 to 2200 megahertz.
Okay. Got it. Anything else?
That's it on that. No, nothing at all on certification.
Okay. There we go. All right. Does anybody have any other old business they'd like to discuss? If not, we'll move on to new business. Our next meeting will be Wednesday, May 18th. Presentation will be by Eddie Vanderkerken from Sorcerer. They sell test and measurement equipment. So he's going to show us the newest developments on test and measurement tools for the broadcaster, including next-gen TV. Wednesday, June 15th, we have a presentation by Al Kornak from TVU. I don't have a title or synopsis for that yet. Some of you weren't in the Zoom yet. We were talking earlier about doing summer meetings. I don't think we will do July and August unless I get somebody that comes to me and wants to do a presentation badly. And it might be somebody that would be an exhibitor. I don't want to say no to somebody that might want to exhibit at our show. So we'll play that by ear. But I think we're going to have enough to do working on the expo this year that we'll do what we used to do and not do summer meetings. I know during COVID we were doing them, but the plan right now is to not do July and August, and then September would be the expo. Notes from Jim Ragsdale, the executive director at National. There's a lot here. He sends a good page full of notes every month out to all the chapter chairs. So I'll just go through these kind of quickly. They'll be at the NAB show, obviously, with their booth and a big presence out there. Upcoming webinars. If you haven't been in on the CBNT and CBNE study modules yet, I did the first two. They're pretty good. So, and they do have the first two posted, so you could go back and watch those. It's an 8-part series. Module 3 is coming up on May 3rd. Wayne is very thorough, and it is study material for the two exams, the CBNT and the CBNE exams. May 12th is our safety course. May 17th, module 4 of the CBNT and CBNE study. And July 7th would be module 5. July 23rd is module 2 of Introduction to Successful Troubleshooting. Deadline to renew your membership was April 1st, but you can still renew if you haven't yet. So if you haven't, you might want to take care of that right away. You could call Kyle Jones, the number's listed there, or email him, or find more information at SBE.org. Leadership development course is full. There is a waiting list, so if you'd still like to get in on it, they're saying some people will cancel, so might be a good idea to get on the waiting list. If you still want to do that, call Kathy Rose at National. Certification for the next exam, the registration window is closed, so the next possible opportunity is the August 5 through 15 exam window, and your application must be in by June 10th. Membership drive started March 1st, runs through May 31st. You could win a trip to the national meetings at our expo in Syracuse or in Liverpool. There are other good prizes. They were listed at the beginning of the Zoom meeting, and they're listed on the national website. The compensation survey has started, and the SBE National would like you to go online and take the survey, and that'll be active through May 16th on the SBE.org website. Our expo, as we mentioned earlier, September 29th is the exhibits and papers part of the show. It's also the national membership meeting and awards dinner. National fall meetings, board meeting, and other meetings will be held on Wednesday, the 28th. Exhibitor booth and sponsorship registration is open on the website. Gateair purchased a gold sponsorship back a while ago, a few years ago, and then COVID hit. We had to cancel the show, but we granted them carry over to this show with their sponsorship. 9 booths have been sold total. Some of those were from the canceled show, and we've got some new ones too. So there's a total of 9 booth spaces that have been sold. Attendee registration is open on the website. So if you plan on going to the show, you can go on and register now. We don't have presentations yet. We will be working on that shortly. Al Jurison is going to handle presentations again. Our attendee database needs some work before we start sending out emails to potential attendees. Vinny and I will get together, probably do a Zoom between the two of us and put the list up and go through it and weed out people that aren't around us anymore and add people that we know are in the business now. And we may be reaching out to some of you to see if you know people that we don't have on our list that might attend the show. If you'd like to help out with planning and implementing our show, reach out to me. You know my email address. You get emails from me all the time. My phone number is also listed on the website, so feel free to reach out. We'd love to have you aboard, and we can use all the help we can get. And I don't know why my space bar is acting like laptop's doing weird stuff since Windows didn't update the other day.
I say call your
Nice.
IT person.
Yeah. Does anybody have any other new business or anything they'd like to discuss or expand on, something we've talked about? Quiet group tonight. All right, I'll make a motion to close the chapter 22 business meeting. Do we have a second for that? Pete, all in favor, say aye.
Aye.
Aye, opposed, say nay. Did that. And if there's anything anybody'd like to talk about going on in their business or place of work, now's your chance. All's quiet. All right, so we'll turn it over to Eric Shofner from Infinite Electronics. Welcome, and I will unshare my screen and you can take it away.
Well, thank you, Tom, and thank you everybody for inviting me. It's a pleasure. As you saw in my bio, I at one time worked on some 10 kilowatt transmitters HF band for the Coast Guard up in Kodiak, and pretty tall towers. And because of the permafrost up there, all the coax cables, giant heliacs, were laid on the ground with concrete half things, coverings over them. We couldn't bury it, and then the bears would come and chew on it, so you'd have to replace sections of cable quite often. I had a team out there doing some welding on the counterpoise to get that better, which really helped out too. So, but I don't miss my Coast Guard days, especially when I had to climb the towers. So let's see here. Let's get started on the sharing. So this is about an hour, and we can stop at any time you guys want to. I ran through this with somebody, a new employee. I thought it was perfect for them, as it's a good topic for this, and it went pretty well. So off we go. Okay, so our agenda, we'll talk about how lightning works, as you see there, and why we have surge protection. We'll talk about all the things that are needed to be addressed when selecting surge protectors, where to put them, the technologies used, if there's any standards that have to be met or that the surge arrestor needs to be compliant to for various applications and so on. I just threw this in there because I thought you guys might like to see that. And then we'll also talk about some common questions I'm asked quite often by broadcast engineers at various radio and TV stations here and there. So we all know how lightning works, right? It's kind of magical. Okay, that's not the truth, but it was fun, so I had to do it. This is how lightning works. It's all weather patterns, of course, cold air dropping, warm air rising, polarizing electrons, and all that stuff on the cloud surfaces. And then what happens is you have step leaders where charges here want to reach up to the sky and vice versa, and then zap. And when you get zapped, you get that. I love that picture. I found it during the course of putting this together. It's just unbelievable. So I had to share it. All right, this is another theory, and we have a white paper if anybody's interested in getting into the multi-page and pretty scientific about the rolling ball theory. You see a tower here and a little transmitter shack there. It's protected if you keep it in a certain area. I'm not going to get into it too much, but here's your step leaders in a time lapse. It's not the best pictures, but. And now about lightning. So when lightning hits things, it's either a direct strike or a near strike. Now, most strikes are near strikes. It hits the tree down the block, the light pole in the parking lot. In this example, this tower is going to be it's a near strike event for that tower. This is obviously a direct strike. So lightning, being a natural electromagnetic pulse, it will induce surge currents to all conductive cables and things within its sphere. And so this tower, even though it wasn't directly hit, is susceptible to lightning-induced surge currents. So another way to put it is conduction, direct strike, or induction or near strikes or proximity strikes. So these waveforms here, these are industry standard waveforms that simulate a direct strike or an induced strike. So there are certain standards bodies like Underwriter Laboratory, UL, or IEEE. You probably heard of them. And they come up with these waveforms. It's a certain rise time and then a decay. So this waveform 8x20, you're going to see that on surge protection specifications quite often, and that refers to its clamping voltage. At what point do the surge protection components clamp or turn on or short the surge current to ground and then go back and reset to an open device? So this is an industry standard. Every manufacturer who wants to have their products be displayed with a little UL sticker will submit what they've built to certain test criteria that UL puts out there. UL will then independently test the surge protectors, and if they pass all that rigorous stuff using these waveforms, then they get their sticker. So there's some confusion sometimes. People don't know the differences, but somebody will call and say, I need a lightning protection system. And so I just want to qualify with what that means. And that is referring to lightning rods, ground rods, and the down lead conductors here that connect them. This is designed to protect the architectural building from catching on fire. So the lightning rod is attracting lightning. It wants to be hit, and then it safely channels it away. You might see a lightning rod about every 10 or 20 feet around the perimeter of a building or a fuel tank or something like that. So LPSs are not surge protectors. Surge protection devices protect the electrical infrastructure, all the wiring within the building, to keep that from catching on fire and so on. But they can be obviously used together. And in some cases, you might want to do that. A lot of people say, well, I don't want lightning anywhere near my building, so why would I want to put something on the roof that says hit me? Well, do you want your building to catch on fire? Then you'll need a lightning rod. So that just subtle differences. I found this, and so I thought I'd throw that on there. Oh, about LPSs, there are companies that are LPS companies. They're certified, they're bonded, and they're grounding experts as well. So let's say somebody wants to find out what the ground conductivity is at a location they're going to install a transmitter, for example. Then an LPS company can do that. They'll bring out test equipment. They'll test what the ground resistivity is. If it's within whatever good parameters, then great. If it's not, then they will create ground wells. It could be chemical, it could be carbon powder, what have you. But they're also experts on the lightning rod system. And believe it or not, there's a real science to that, and some technologies that I'm not fully aware of, but I know they're out there beyond just the standard copper rod that you put on the roof. They're pretty complex now, and those guys really know what they're doing. We'll see the standard later, but LPS systems are controlled by NFPA, National Fire Protection Agency 780 standard. And so they're experts about that and can help you about that stuff. So surge protectors, we use different technologies in the products themselves. Here's a gas tube, very basic, and the good, better, best. It's a good product. It's depicted here schematically like that. It's a normally open device. It's a voltage limiting device as well, so it's going to react to a sudden rise time in voltage, at which time the gas inside here ionizes, creating a momentary short. The surge then comes off of it. This schematic is for an RF surge arrestor. And in this case, so the surge will be shunted to the body of the surge arrestor, which will require a dedicated ground path to carry on that surge current right to ground. Lightning wants the least path of resistance. And so you want that ground wire to be as straight and short as possible. Any bends add impedance, and then the surge will want to go somewhere else, like through your radio. Well, the one thing about gas tubes is they're degradable. So they wear out a little bit after each surge event, and there's usually no indicators to tell you when. So How do you test for that? With VSWR testing is how you do that. So as this degrades, the VSWR gets worse, and at some point you make a subjective decision on when to replace it, and you do. So another technology is metal oxide varistors, which turns out to be zinc oxide, which is the same component used in diaper rash ointment. So I thought that was interesting. What they do is they bake it, and who knew it was an excellent surge protection device. So now this is also degradable, but it is solid state actually. And a colleague of mine gave a good example of this, of MOV. So consider it like a piece of paper. And after every time it's reacting to a surge event, you're poking holes in that piece of paper. Well, that piece of paper is your conduction material. And so as there's less material to conduct the surge current still wants to get through it, but it's going through now a smaller and smaller pipe, which means that MOV technology gets hotter and hotter as it ages. And at some point it will catch fire. So Underwriter Laboratory, and we'll talk about this later too, they established a requirement for surge protectors that they have thermal disconnects built into them, so that, especially for MOV technology, when it reaches to a certain temperature at the end of its life, then that thermal disconnect permanently disables the surge arrestor and keeps it from catching on fire. So I was showing this to my wife and she said, that looks like the Enterprise. So I just had to throw that in there. All right, so silicon avalanche suppressor diodes. This is the king of surge protection. It's super fast reacting, solid state, and non-degradable. So as you can imagine, it costs a little more, or quite a bit more. Sometimes you can use them in a hybrid circuit, hybrid meaning the surge arrestor has more than one surge protection technology being used. This schematic here shows just that. This is an RF DC pass surge arrestor, and it's a hybrid. So we have a gas tube, we have an MOV and a silicon diode right here. And the DC pass is through these coils here and then out in this particular design. But when you use it this way, usually the silicon is going to do most of, if not all, the work. But then you have MOVs and gas tubes that can handle a lot of energy. And so when they're used together, you get a long life, super robust, really good surge arrestor. Okay, this is kind of cool. We don't use this in everything, but we have some products that do terminal. It's not terminal, actually. I got to fix that. It's a blocking unit. And what it does is there's a circuit here, schematic symbol, that as current rises, so does impedance. The more current that's flowing through it, the more impedance it creates here. So when current wants to make that least path of resistance to ground, and it sees this here, it's seeing more and more resistance. It doesn't like it, so it wants to go somewhere else. But you don't want to just trust that. So we always add a gas tube here along with it to handle any residual surge currents that get through it. Transient, that's it. Transient blocking unit. So I have to fix this. TBU stands for transient blocking unit. Okay, something else we use or can use is a filter system. Now, some of you may already have this installed. It's kind of old. There's a brand called LEA International. They were their own company based out of Tampa, Florida. And for many years, well, back, let's see, about 30, almost 40 years ago, they were purchased along with Transtector by a company called Smith's Group. Then they merged the companies, and the surviving legal entity was Transtector. So, but Transtector still makes LEA products. And in this case, what we're looking at here is a series connected surge protection device. And what these arrows point to is the indestructible EMI RFI filter network built into this thing. So here's the coil, and then these cans up here and down here are the capacitors in the filter network, removing EMI and RFI off of the incoming utility power line. So broadcast love this just for that reason. If you can remove noise from the AC, that you don't have to work so hard after the main breaker and with all your other equipment to remove noise. So why is this here? We'll get to that in the question section later, but it's also a good visual to show you that there are surge arresters that are series connected as opposed to parallel connected. And series connected units will have usually will have a nice filter network shown schematically here. Okay, so kind of simply, these surge components that we just looked at, they're usually in parallel between, let's say, the line and the neutral, or it could be a data plus and data minus, or a DC plus and DC minus. And it's a switch. It's basically what it is. So it's normally open until it reacts to the sudden rise time of voltage. Then the switch closes, shunts the surge to ground, and then opens again. So the lightning event is a microsecond duration, and power spikes from the utility company, well, they should be that, but that's quite different from what's called sustained overvoltage. That's another whole issue, and surge protectors are not designed to mitigate that. They'll die. They don't like that. Okay, so here we look at the parallel and series connected surge protectors, and what's the difference? Well, a series connected surge protector literally means that the line, the neutral, the ground is coming in and out of it, and then into a breaker. This is equipment, but consider it a breaker, like the main breaker. And so let's say this thing fails and you want to get rid of it, you'd have to shut down the power to the entire building and then remove this device. So instead, we have parallel connected surge arresters. Now, a parallel is connected to a dedicated breaker in the breaker panel, and then it protects the loads on that panel. And if this thing fails, you just secure the breaker to the surge arrestor, not to the whole building, and you can replace it or do maintenance on it. You wouldn't have both, but later on, you'll see why you would want both. So this is here visually just to show you the differences. And then schematically, you see the components here. These are the surge components. And I like this slide too, because the surge arrestor can be a common mode protector or a normal mode protector. And what's the difference? With a common mode, you have components that are between like line to neutral and neutral to ground and line to ground. That's a common mode protector. If you don't have components that go to ground but are literally just between line and neutral, and that's all, that's a normal mode protector. So you would use a common mode in areas where the power quality is just terrible. But if otherwise, and if you're familiar with Motorola R56 standard for land mobile radio, they say thou shalt never use a common mode protector. And the reason why is for that moment of shunting of surge current, then that ground connection could possibly create a ground loop scenario. And so for critical 911 radio systems, they don't want that to ever be a possibility. So they say, thou shalt not use common mode. But if you're at the end of the power line in a rural area and your power is crappy, you kind of might want a common mode protector. So there's reasons, and you just got to kind of weigh things and decide which one you need. So where does the surge current go if there's no to ground connection like here? What happens is the surge component here will shunt between the line and neutral, consider that neutral, and then the surge current will find ground through the neutral to ground bond at the main breaker panel and to ground from there. So that's how the normal mode protectors work. So in terms of standards, there's quite a lot, and all of these have something to do with surge protection, whether it's AC or data or what have you. And when this is all over, I'll provide, this is a 25 megabyte PowerPoint, but I can get it to Tom, and then Tom can distribute it to whoever wants it. So some of these slides could be, useful for references if you ever wanted them, like this one, this slide. But the one thing I wanted to show you here is Underwriter Laboratory, and the UL 1449 4th edition is the latest edition. That is the one that is the standard for surge protection devices. The UL 1283 is about EMI filtering, so that the surge arrestor, if it has that requirement, then it needs to have that capacitive inductive filtering network built into it. And this 96A, that's It's kind of nebulous, but I put the definition here for you. UL 497 is a standard for like DC protectors and data protectors. So you'll see that for that. National Electric Code is very critical. That is the standard for grounding, along with National Fire Protection Agency code here. And Motorola R56, they wrote their own standard for installation and grounding for 911 call center type stuff. And Transsector actually helped them develop their Chapter 7 on surge protectors, actually. And they're very, very strict. So in addition to where the surge arrestor will be installed, the R56 Chapter 7 also tells you not only where, but what technologies to use. And in addition to that, thou shalt just use normal mode protectors. And very strict. Now, ATEX is another one, along with Intertech, which refers to hazardous location certification for a surge protector. And that means that the device, if it has been submitted for that certification for testing and it passes, then it's intrinsically safe, which means when it's operating, it will not throw a spark. And that's really critical for surge protection or electronic devices that operate around oil refineries and oil and gas fields, gas stations, anywhere where there's explosive gases. So not all surge arresters are certified to that, but if you ever see hazardous location certified Class 1 Div 2, that's what it means. Okay. We also have to, we also sell to, or that there is surge protection in elsewhere in the world besides North America. So the IEC is the standard for Europe and internationally. CE as well. The IP and NEMA ratings refer to weatherization. So if it's an outdoor related type scenario, IP is usually for components and NEMA is for enclosures. So, you need it out to be in an enclosure outdoors, then you'll see a NEMA rating. If it's just the surge arrestor itself, like an RF surge arrestor on a coax cable, and it's exposed to the weather, then it should have this rating, an IP 65, 67, 68 rating. Then you know it's weatherized. So where to install them? Well, IEEE and UL, they came up with, this is an older chart, but it refers to these A, B, C locations. And C, well, this is older. This is a newer one, where they've gone to type 1, type 2, and type 3 location certified surge protectors. So this is kind of backwards, but C is similar to type 1, which means the surge arrestor location where it's going to be installed will be between the meter and the main panel. Not at the main panel, but between those areas. So that surge arrestor, if to be type 1 rated, has to be built a little stronger. It has to be able to handle more current than a surge arrestor that's not type 1 certified. Type 2, or the B location, is the main breaker panel or any sub panel down leg of the main. That's type 2. So most surge arrestors are type 2. If it is type 1 rated, by default, it's also type 2 because it's just beefier. So if it can handle type 1, it can easily handle type 2. Type 3 is point of use. So that could be a 19-inch rack where the radios are, or network servers, or it could be the operator's console where they throw a power strip under their desk and they are plugging in their monitors and computers and things like that. So anything you plug in is a type 3 or point of use. And this is just another slide showing the same kind of thing. I like this one because it gives you an office view. So, but this is talking about type C, which is type 1, type B, which is type 2, or category A, which is type 3, points of use. This is a slide out of the Motorola R56. And I like this one because why just put it at the main entrance? Well, there's reasons why you might want it elsewhere in addition to the main entrance. And in case of R56, they want it everywhere. So this is this shows you what's called a cascading surge protection plan. So there'll be a surge arrestor at the main panel, usually in front of an automatic transfer switch, protecting the ATS. And then they'll have another surge arrestor at critical sub panels that feed power to the 19-inch racks with the radios in them. And then they'll also have the Type 3 plug-in stuff. And the reason for that is because lightning will attach itself, it will induce surge currents to all conductive cables in the lightning sphere. So, and now a lot of people say, well, I need a whole facility protector, which is the main panel. Okay, well, we can do that. But if your critical $100,000 piece of gear is at the other end of the factory, 300 cable feet length away from the main entrance, then that main entrance is not going to protect your thing 300 feet away because of induced surge currents. So you'll need to put another surge protector somewhere else. Now, so if you use a cascading plan like this with a surge arrestor at strategic panels, then you're dividing and conquering that surge current, but more critically, the critical gear will be properly protected. So all of these little arrows here show you different sources of where surge currents can be induced to and brought in. And in this scenario, the chain link fence needs to be grounded. The metal building needs to be grounded. Any cables coming in, every single thing that conducts, if you don't put a protector on it, that's the back door for the surge current. And now you're replacing gear. And this is just another way to show you schematically in an architectural electrical drawing that where you're putting surge protectors where they need to be. All these are different breaker panels. And here's another image showing you that surge arresters are the sacrificial lambs. So we have a tower here with a little microwave dish, parabolic, and maybe there's a security camera. And so there'll be AC power running up and data. Could be, like Ethernet, for example. And so here we have, let's say this is a 50-foot tower. So you'll have data protection at one end of the data cable near the equipment on the tower top and at the source, let's say near a switch, an Ethernet switch. And the reason for that, again, is induced surge current. So where surge protectors have a sphere of influence of about 40 feet, so anything beyond 40 feet is a problem. And with data cable specifically, it's not uncommon to have 100 foot, 200 feet of data cable running up a tower. So that data cable itself is the source of the surge. And so you'll put a data surge protector at both ends of that same data cable. And they may be marked at each connector, RJ45 connector, line and load, the line being the source of the surge. So in this scenario, with the two data protectors, the line connections of those data protectors will be looking at each other because the cable itself between them is the source of the surge. And this is just to show you that you'll need surge protectors for various things all over the place. Different applications. Now, this is a really cool slide. I love this one. So Transtector did a test. This is a fluid mesh radio. There's two of them here. And with one of them, they set up a test where they're going to impulse it with a simulated surge event. Where did it go? And the other one is protected. One is not protected. The other one is protected. Here's the test setup. And down here are the results. So you can see voltage here. This is how much voltage got to the equipment during the test. And all of these taller lines are the unprotected radio. And the protected radio, the voltage was limited to below 600 volts. So surge protection works. Very critical to surge protection is grounding. So that's really foundational. If that isn't done correctly, then it's kind of a moot point. So just real quickly, these are copper straps, here that run down the side of a building at a cable entrance to the facility coming down from the tower, and you'll see that here, well, right here. This is not associated with that picture, but you get the idea. So cable entrance, and in this case, the cable entrance has these straps coming down and going down to the earth ground system. On the other side of that panel is this. So the cables come in and terminate. You put your surge protector here, and the surge arrestor gets its dedicated ground path via the strap to the ground bar on this copper plate, which is also your ground system, which then gets grounded through these air to ground. So this is all about making sure you have a single point ground system, which is required by National Electric Code. All grounds have to tie together. So if there's multiple ground rods, they have to tie together. If you don't do that, like in this little image here, it's possible that this grounded location might have a difference of potential that's not the same as the one that should be the main one. So what that means is that if you're measuring, let's say, well, I have 5 volts here, but let's say you're measuring 120 volts outlet. If your ground potential is voltage is 0 volts like it should be, then you put your DVM in the thing area, you should measure 120 volts. But if your ground potential is, say, 50 volts, then you're going to measure 170 volts because it's relative to the ground voltage. So if there is a difference of potential from this location to that location and you don't tie those grounds together, that's what's called a ground loop. And that can cause premature equipment failure because now the equipment is suffering from 170 volts instead of 120 like it should be, or whatever it is. And it's also a human safety issue. So if you tie those grounds together, then all voltages throughout the location there rise and fall together at the same potential. And that's the point of a single point ground. So when you do bond grounds, there's 2 preferred methods per National Electric Code and such. One is what's called a permanent crimp, and the other is exothermic welding, or CAD welding. Some people call it that. CAD-Weld is the name of the company that provides this mold. And what you do is you'll put your wires together, like here, you're bonding a wire to a ground rod. So the mold has slots to bring in the wires and to wrap around this. And when you close the mold, you're pouring in some like magnesium and other powders in here. You flip this lid over and you step back and you light it off, and in seconds, over 2,000 degrees, melts all that metal together into a molecular solid piece. So that's why exothermic is preferred. It is just the best way to go, or a permanent crimp. Okay, so with ground bars, metal ground plates here, bus bars, or any metal surface you're attaching a ground or a surge arrestor to, like an RF coaxial surge arrestor, you want to have those ground connections or the surge arrestor having metal to metal contact with the ground bar, and you want to use a conductive joint compound between the surfaces. And by doing that, you're maintaining a really good conductivity, you're preventing corrosion from settling in, and it helps with mitigating dissimilar metal or electrolysis problems, say by copper and aluminum, for example. So just the metal table here. Now, these are all just different examples of conductive joint compounds, or it could be penetrox, it could be, some people call it anti-Cs. In the Coast Guard, we call it anti-Cs, and it was molybdenum based, but it could be zinc based, it could be whatever. This is a polyphaser one, and it's copper based. And you can just see a little bit of the goo here on this example where somebody used it. Good practice. Okay, this is the other end of that picture with the straps going into ground. Now this is 2 8-port copper entrance panels that are bonded together side by side. And each panel here comes with 2 of these 6-inch wide straps. Okay, and now, so the cable we recommend, let's say you're hanging this is an RF coaxial surge arrestor, and it's not mounted to a ground plate. It's just hanging out in the air, and it's weatherized properly, but it still needs a dedicated ground path. So you use a ring terminal So what size cable do you use? You use a 6-gauge stranded. So lightning surge current it travels on the surface of the conductor, and you get more surface area with a stranded wire than a solid wire. So we always recommend a number 6 stranded, not solid ground wire. If you are attaching it to a ground bar, and you might have multiple surge arresters like in this image, it doesn't kind of show it, but the ground path from the ground bar to the ground system needs to be a bigger pipe than 6-gauge, because you're combining surge currents on that bar. So you might want to go with a number 4 or a number 2 gauge from the ground bar. But if you're just going to a single surge arrestor, then the magic number is a 6-gauge strand. And that was derived, it's an industry standard, but Polyphaser did their own study many years ago, and their results were that an 1.5 inch wide solid copper strap, which is equivalent to 6-gauge stranded, is as much copper as you need. Anything more than that to a single surge arrestor is overkill. Okay. And this, I just wanted to throw in here some examples of yucky grounds. This is so critical that where you have them and where you can inspect them, you should, and to maintain them just like anything else, because this is so foundational. And this is such bad examples. It's not untypical. If you're having problems with grounding and getting shocked, inspect the ground system, and you'll probably find examples like that where they were pristine 25 years ago, but they've corroded and they need to be maintained. Come on. Okay. I like this one because from my Coast Guard experience, we used hot towers. They could be 200 feet or even 1,000 feet, depending on what it was. And so we have a base insulator here, ceramic or something, but we need that surge current to go to ground, and you do it with those ground gaps here, little ball gaps. This is the AC toroidal transformers to transfer the energy up there to power the aircraft warning light or what have you. And what this is a tower that's a LORAN tower, 1 megawatts. I was not a LORAN tech. I was the shipboard electronics guy, but I worked with guys who were in this field, and they describe what they called a Z feed. And what that is this is your antenna coupler building. And so this is the RF path getting to the top of the tower, top of the insulator. And what they've done is they've bent it in 2 different 90-degree bends here to make this a sour path for the surge current when the tower gets hit, or from induced surge current. And then on this downward leg here, even though it carries up again to the connections here, there's also a path that comes here and another ball gap to ground. So any surge current that does wind up making the turns will want to jump here and not get into the antenna coupler. That's the idea on the RF path, but you can't see them, but there's still ball gaps over here somewhere, like these. I just threw these in for reference material, but it's critical to know, if it's an AC surge protector, the exact voltage configuration of the panel. Now, we talk to a lot of electricians who say they want 240 single phase. And so when I ask them how many hot phases there are, they tell me 2. Because, if you measure line to line or phase to phase, you're going to measure 240. But if you measure from neutral to either leg or line, you're going to measure 120. That's what this means. So, but they call it 240 single phase, but there's 2 phases. So if I didn't ask that qualifying question, I would sell them a 240 volt single phase surge arrestor. They would get it and say, this is the wrong part. Because you really wanted a 120 240 single phase. And in terms of the surge protector, language matters. If it's 1 phase, it's 1 phase. If it's 2 phase, it's 2 phase. And these are just examples for future reference if ever you ever want them. But here's a 3-phase Y. It's spelled this way, and because of this, these are the transformer windings that derive a 3-phase Y scenario. It could be 122.08, 277, 480, and so on. This is a delta, which doesn't have a neutral, shaped like a delta. So that's pretty cool. And this is a very old and unusual configuration called a high leg delta, which does have a neutral. Mostly in the south, but they're out there. Is that it for that? Yeah, okay. So we're getting now down to the end of this broadcast, of this presentation here, and what we have are some questions that I'm asked regularly by broadcast engineers. And one of the most often asked questions is this one, and the next question is we're putting in a new transmitter site, and what surge arrestor do I need? So we're going to ask you about voltage, what voltage configuration you need. Would you like filtering or not filtering? And whatever your other requirements are. But for broadcasts, having a filter is great. Like I say, it eliminates some noise from the incoming utility. And so there you go. And then the next question, and this is very commonly asked, is I've got this old LEA product that it's a series connected surge arrestor. And the MOV modules that are in there are shot. Do you still support that? And the answer is no. So we got out of selling series connected surge arrestors. However, what I tell folks is that this filter network is indestructible. The MOV protection is not there anymore. So you're not being protected from surge if you have this device, but you've got one of the best DMI RFI filters ever. So what I recommend you do is you keep this in place, because to remove it, you'll have to secure power to the whole building. And instead, install a parallel connected surge arrestor like this one, which has filtering built into it. So this particular one has MOV modules and filter modules separately. Okay, now sometimes, I don't get asked about this a lot, but do you have surge protection for 10 kilowatts or greater? Ages ago, polyphaser had that. It was this, which when you look down the barrel, it's this. It's basically a gas tube inside this giant rigid heliax with, I think it's called EIA flange connections. We no longer have that. So polyphaser sold that design to Fisher Custom Communications. If they still sell that, I don't know. But if anybody needs that, now you know where to go to look for that. But polyphaser no longer has this. That's just another example. So for RF coaxial surge protection, where do I install that surge arrestor? So a lot of folks want to, not in the broadcast world, but other people sometimes say, I want to put it right at the antenna on my tower. And I say, well, that's a waste of space. Remember that 40 feet of influence? It's not doing any good on a 100-foot tower. So put it at the cable entrance where the cable penetrates, like here. But if your transmitter or receiver or radio is 200 feet away, then you need another one on the same coax cable about 2 or 3 feet from the radio. So I can have two on the same coax line. That might add impedance. Well, it's going to add a little impedance, but remember induced surge current. So you have one here. It's doing its job. It'll remove surge current there. But if your radio is 200 feet away, it's still susceptible to induced surge protection or current. And I'm going to install that right on the RF port of my radio. I says, don't do that, because when that surge arrestor is shunting surge, there could be 30,000 amps on that body of the surge arrestor, which is now touching the chassis of the radio. So you want to have like a 2-3 foot jumper cable between the radio and the surge arrestor if you have one in the building somewhere 200 feet away. And so where do I ground that? It's in the building. I said, well, I don't know. Every scenario is different. Consult a licensed bonded electrician. Where you safely ground things in a building is part of National Electric Code, and so an electrician should be able to help you. What's it mean for RF coaxial surge arrestors to be directional or bidirectional? So that's a great question. With RF surge arrestors, the RF direction is always bidirectional, but the surge arrestor, so these terms are referring to physical alignment on the coax cable. And with polyphaser stuff, you'll see one connector has antenna, or it might say surge near one on the external label on near one connector, and at the other connector, it'll say equipment or protected. This is a directional unit, as the schematic shows. We want the gas tube to be closer to the source of the surge. So that's why it's directional. If the surge arrestor, like in this design, if the external label doesn't show antenna and equipment on the label, like this one does not, it's bidirectional. And as the schematic here shows, performance is the same regardless of which way you point this thing, so it doesn't matter. So that's what we mean by that. What's the difference between a DC block and a DC pass surge arrestor? So that's all about the antenna. If the antenna is passive, like a whip, a Yagi, or a dipole, then you would want a DC blocking surge arrestor, where we have a DC blocking capacitor on the center pin, which blocks the DC component of a lightning strike. It's just added protection. If you have an active antenna, like a GPS antenna that has a preamplifier in the antenna, so there's a circuit board in there with components that requires a DC voltage to operate, and that voltage is transferred to the antenna by the receiver through the coax cable. So anything you install in series on the coax cable has to pass that voltage, or the antenna is useless. So you need a DC pass surge arrestor for, like, GPS timing signaling equipment, for example. You would have to have that. And if you're calling me and asking me which surge arrestor you would need for, like, a timing signaling network thing, GPS, then I would ask you what the antenna operating voltage is, which is not going to be the same as the radio's input power voltage. So the radio will send whatever the antenna needs. It's typical to be 5 volts, 24 volts, something in that range. And the reason we ask that is because this particular product is our premier DC pass product. It's a hybrid using everything. And they're designed for certain up to voltages. So if your antenna needs 5 volts, you don't want to put a 60 volt thing on it, because it would pass up the 60 volts. That's too much. We actually make a 6 volt and a 15 volt that lets through much less voltage to your receiver. So use the right surge arrestor for the right antenna voltage. So in the DC pass world, this is the premier one with everything. This is a straight gas tube design that's also DC path, because there's no capacitor on the center pin there. It's just a wire. But this is good. This is best. Okay, how do I attach ground to a coaxial surge arrestor? It depends on whether it's going to be bulkhead mounted, if it's going to be flange mounted. So if it's bulkhead mounted and that's a metal ground plate, then the ground wire goes to the plate. If you're flange mounting it to, like, a flange bracket and then to a plate, then again, the ground wire goes to the plate. Or if the plate here is attached to something non-metallic, you could attach the ground wire to the plate or that bracket. If you're just hanging it, then use a ring terminal, either for the end connector, or this model has a little threaded insert and we provide that bolt. So you would attach your ground there. And again, use the 6 gauge stranded. You can also use the 1.5 inch strap using a certain little gadget we provide. So I've got a gas tube surge arrestor. How do I know when the gas tube is worn out? Well, you'll do VSWR testing, like I mentioned. I threw this on there because this is what I used many years ago. It's a watt meter bird technologies. You may have seen that. And but I understand now they're much more sophisticated and sometimes built into the radio itself or some gadget in a 19-inch rack. But that's basically all you're doing. As the gas tube degrades, it negatively impacts VSWR, gets worse. And what I tell folks is, let's say you think that the surge arrestor is bad. Before you jump to that conclusion, replace the surge arrestor with a barrel pass-through and then retest. And if the VSWR gets better, bingo, surge arrestor, replace it. If your VSWR stays bad, well, something else is wrong. You got water in the coax line, the coax connectors are dirty, the antenna might need some attention. You got to resolve that issue and then retest with the surge arrestor to know that for sure that the surge arrestor is the reason why VSWR is going bad or not. Weatherization on coaxial surge arrestors. Polyphaser sells a kit where you get this self-vulcanizing. It sticks to itself, but it's not sticky. It's a rubbery tape. that's your first layer, which is this here. And you wrap that around, okay, get it all nice and tight. Well, it can come apart easy. So the second layer is just standard electrician's tape, sticky. So you'll overlap the first layer with the second layer. Now, that's as far as polyphaser goes, but in the Coast Guard, we added a third layer. We painted on this goo, Scotch coat, and it was specifically designed to paint over vinyl cable splices that are intended to be underwater. So for the Coast Guard, that was ideal. So you paint over the tape layers with this goo. There's a brush attached to the lid. You unscrew the lid and you paint it on. Don't get it on your clothes. It'll never come out. But in 24 hours, it hardens into a UV and water resistant shell. It'll never come off unless you cut it off. And it's just fantastic. So just use the 3-layer method. It's best. Now, we don't sell Scotch coat at Polyphaser, but you can get it online. That's just one resource. Okay. So we've got data protection, and we talked about that, camera protection, for example. So this is a picture from we did a test with Axis, which is a very expensive security camera company. So that's their camera here. And then we used an outdoor data protector, gigabit power over Ethernet, and one down by the switch simulation. And the results were just great. And so again, you got long data cables going to your tower top, whether it's radios or it's a camera, you'll want to use a surge arrestor at both ends of that data cable. And this is just showing that data cable, and with data cable, this is why this is a great question, because a lot of people ask about it, is do I ground both ends of the shield on that data cable? And the answer is no, because when you do that, you could cause a ground loop scenario. So, well, which end do I ground? Water runs downhill like Trons, right? So you want to ground the end of the data cable closer to the ground, not at the tower top. So that's really that basically simple. Oh, yeah. A lot of people say, well, do you need surge protection at your point of use? Well, I got a UPS. I don't need it. That's why I put this in here. UPS systems are not surge protectors, but it's got surge protection built into it. No, it's got a surge protection circuit that's like a few components. Okay. So you see your UPS, it's big. A surge protector is big, and it's designed to be a surge protector. So you want to put a surge protector in front of a UPS. Let the UPS do its job, because if the UPS's surge components fail, the UPS is dead. So if you want something to be a sacrificial lamb, use the surge protector and let the UPS survive. So you use both. Don't rely on a UPS that has built-in surge protection. No. And that is the end. Now, I threw this on here. This is a cool picture from the University of Florida in Jupiter, Florida. So they conduct tests, and they do that with a rocket. So this is the result, the picture. It's a fantastic picture. So for $10,000, they shoot a rocket with a wire. This is the wire being vaporized, and these are natural strikes. It's pretty cool. And this is just a cool picture of a bunch of towers getting hit. But I wanted to ask you, does anybody know which TV tower that is?
Sutro.
You got it. And I don't know if you know this man here, but he is standing right around one of these things up here at the end. And his name is Merrill Weiss. I don't know if you've met him, but he's a consultant to the U.S. government. And he was pretty influential in the digital transition back in 2008, whatever it was. And he's now working on, you mentioned next gen, the ASTC 3.0, ATSC 3.0. He's working on that right now, and we've talked because he needed a few things for his development of some of that technology he's working on. So he shared this picture with me. He says, "Guess where I am?" And I go, "Sutro Tower." I'm from the Bay Area, so I knew it. And then my last question for you guys is I wanted to know, what is the tallest TV radio tower, whatever? And Google gave me this. It's not the tallest, but it's the second tallest structure in the US, 8th tallest thing in the world, but it is a radio station. Does anybody know where that might be?
Is it in South Dakota?
That is exactly right. It's KXJBTV, Valley City, Trail County, North Dakota, 2,060 feet. And that concludes my presentation. Anybody have any questions?
Do you care if we post this on our channel?
Not at all. Nope.
Okay.
And if anybody has questions about anything that's in there, I'd be happy to talk to you individually or as a group. I can get back together with you and do that.
All right.
I'll get this to Tom. Anybody else?
Well, thank you, Eric.
You're welcome.
We get frequent surges from the power company. Right now, they've got a monitor on our line, so I'm kind of curious to see what those surges are when they come and check it. But, do you run into that a lot? And what's
Not
the
a lot, but
solution?
it happens where somebody's reporting. They'll call us and they say, I've been putting in a lot of surge protectors. I've lost some other gear. What's going on? And that it's almost always something to do with grounding.
Mm-hmm.
Now, back in the day, the founder of Transtector, his name was Richard Odenberg, and you may be familiar with RO Associates. So RO stands for Richard Odenberg. And that was a side little thing he did with Transtector where he put together a small team of electrical engineers, and they were very, very smart about National Electric Code and the other standards and codes. And they would conduct what's called a site grounding inspection. So they would go to your facility, they would bring their fall of potential test equipment to measure your ground resistivity and ground potential, other test equipment and they would do an inspection of your entire electrical infrastructure.
Mm-hmm.
And what they're looking for is that everything meets code. That's what they're looking for. And so it'll be obvious to see when it doesn't. So an electrician would follow them around and open the dead front panels of breaker panels so they could observe in there. They would open the canisters or covers of transformers so they could look in there and literally just walk around, and they would take pictures, they would make comments, and you would get this big detailed report with anything that didn't meet code in giant red letters, so it was unmistakable. And then at the end, there'd be a recommendation on how to restore these things to get them to code. And so that's what would be needed. But to start that is exactly what you're doing, is if you're having issues and you suspect rotten power, call your power company, ask them to put a power meter on your main panel on the meter. They'll record for a couple of weeks and then they'll analyze that. It'll record everything. And if they see a problem that's on their side, then they should fix it. But otherwise they're not going to go into your building and help you resolve any of that. So they only go to their meter.
Right.
So then you'll need to consult with somebody now, all those engineers with RO Associates, they're all retired now. There's only one guy still working, and he's an independent contractor now. So we kind of disbanded that service, but that guy's still available and we have access to him. So if it's something you're interested in, we can connect you with him.
Okay. Anybody have anything else? Guess not. So I hope to see everybody again on May 18th. And have a good month. And thank you again, Eric.
Thank you again for inviting me. I enjoyed it and hope you got something out of it and appreciate it. And I'll get you this presentation. I'll email it to you, Tom.
Okay, great. Anybody that wants it, let me know and I'll get the word out too that I got that. So, okay, thank you.
Thanks, everybody.